Welcome to the Solocast of Firecode Tech. In these episodes, it's just going to be me, your host, Gus Gagliardi. There's going to be a range of topics, but I'm going to talk about specific technologies, installation standards, codes and how they work, as well as some other interesting topics that don't neatly fit inside of the context of a normal interview. Hello all. Welcome to episode 47 of the Solocast series of Firecode Tech. On this episode, we're talking about dry pipe systems. Yes, dry pipe systems are fairly common, and so I wanted to break into components, design, tips and tricks, advantages, disadvantages, and much more about dry pipe systems. Just as a little bit of housekeeping business, it's our 110th episode of Firecode Tech. Yes, we've been doing it for over 2 years now, coming up on our 3rd year next April. And I'm just excited to still be doing the podcast and still for the audience to be growing. And so, I just want to say thank you guys. I didn't celebrate at the 100th episode, but we'll have to do something special soon. Do me a big favor and hit that subscribe button. Oh, and if you enjoy the podcast, you could tell somebody about it and spread the word about Firecode Tech. I often take fun resources that I enjoy in fire life safety and use them as teaching tools or informational handouts to people that I work with. And so if you can think of somebody in your life when you have a topic come up, like say dry pipe systems, and somebody needs a precursor on the subject or maybe just a little bit more information, reach out and send them an app. Anyways, let's get into the show. First topic I want to cover is what is a dry pipe system? Well, first of all, let's go to the standard in which we're going to find this definition, which is NFPA 13, 2022 edition. In Chapter 3, more specifically 3.3.216.4, which is titled Dry Pipe Sprinkler System, we get the definition that covers what this type of fire sprinkler system is. It states, a sprinkler system employing automatic sprinklers that are attached to a piping system containing air or nitrogen under pressure, the release of which, as from the opening of a sprinkler, permits water pressure to open a valve known as a dry pipe valve, and then water flows into the piping system and opens sprinklers. So the real crux and the value add of a dry pipe system is that it is not normally charged with water. Dry pipe system is used as a form of freeze protection for an area within the building that cannot be maintained above 40 degrees Fahrenheit. So that is a little bit about what a dry pipe system is. One of the main component pieces that is different for a dry pipe system is the dry pipe valve that is mentioned in the definition previously. Another name for a dry pipe valve is a differential dry pipe valve, and there's a definition in Chapter 3 that describes what this is. It says a water control valve that is held in closed position by system gas pressure, exposed to the surface area of air/nitrogen on the side of the clapper, where the surface area is larger than the surface area of the water supply side, with an intermediate chamber between the two surface areas that is open to atmosphere. The dry pipe valve, or the differential dry pipe valve, is held closed by air and or nitrogen. We'll talk about later why you might want to use nitrogen, but suffice to say that the gas pressure holds this differential clapper valve shut, and when the sprinkler opens, the air first exhausts out of the sprinkler opening, and then the piping fills with water and then expels water out of the sprinkler head. Let's talk a little bit more about when a dry pipe system is required. So we said before that it's a means of freeze protection, but there's a specific section in NFPA 13 which describes the conditions in which you need to provide some sort of freeze protection. That section is 16.4.1.1, and this section states where any portion of a system is subject to freezing and the temperatures cannot be reliably maintained at or above 40 degrees Fahrenheit, the system shall be installed as dry pipe or pre-action system. So we're not talking about pre-action systems today, but suffice to say there are a number of means for freeze protection. And if you're interested in learning about all the different types of freeze protection, you should go check out our episode on the subject. That is Solocast number 37. So assuming you have a building or structure in which you've installed a sprinkler system or a sprinkler system is required, and you have a space that is required to be sprinklered that cannot be maintained above 40 degrees Fahrenheit, and the project stakeholders have decided that dry pipe system is the appropriate freeze protection means for how to fully sprinkler this space, then you need a dry pipe system. That's a long, drawn out way to say how you need a dry pipe system, but it's a little convoluted and complicated, and there are several options like mentioned. So like we already said, with NFPA 13 is the installation standard for dry pipe systems. In section 8.2, there are specific criteria for dry pipe systems, and also you can find other provisions throughout the standard. Also, when you need a sprinkler system is governed by the building code that is adopted in the project that you are working in. So let's talk about some of the components that are different for dry pipe systems than wet pipe systems. Well, the biggest piece is that differential valve or the dry pipe valve, which we already covered. Secondly, you need some sort of air, whether that's just standard air from a compressor or nitrogen from a nitrogen generator or a bottled supply of nitrogen. One way you can recognize if you have a dry pipe system as compared to a wet pipe system is there is additional valving trim and extra pressure gauges associated because of the pressurized air on the system. So if you see a lot of extra trim and piping around the valve, you can generally be aware that it is likely not a standard wet pipe system. Dry pipe valves, unlike wet pipe sprinkler systems, use pressure switches for low air supervisory and water flow. So instead of a paddle type or vane type water flow switch, a pressure switch is set to trigger at specified air pressures that include low air supply and pressure flow that indicates water flow. So let's talk about some of the advantages and disadvantages of a dry pipe system, specifically in reference to a wet pipe system. So by and large, dry pipe systems are less effective at fire sprinkler protection, 1-for-1. The first reason why you can be sure of this fact is that for dry pipe systems, the design area for the hydraulic calculations is increased by 30%, and this is because of the delay in activation due to the need to exhaust the air from the piping system before the water can discharge. Another big design challenge for a dry pipe system is the difficulty with draining and how trapped water in piping can cause an area that is subject to freezing, which is the whole reason why you are using a dry pipe system. So you have to be very aware of the slope and the pitch and the collection points of water in your system, because if you have even a small amount of water build up in trapped piping segments, you can really degrade your piping. Another big disadvantage of dry pipe systems is that their lifespan is a fraction of wet pipe sprinkler systems, depending on the wall thickness of the piping used, and if nitrogen is used in lieu of standard air for your air supply, then you can extend the lifespan of the dry pipe system, but it will still likely be anywhere from half to a quarter of how long a wet pipe sprinkler system will last in years. I'm realizing now, talking through these advantages and disadvantages, that these are mostly disadvantages, and I still probably have about 4 more, but the one advantage is that as far as means of freeze protection or sprinkler coverage for areas that cannot be maintained above 40 degrees Fahrenheit, is that you don't have to worry about the added maintenance or dealing with antifreeze solution in comparison to antifreeze systems instead of dry pipe systems. And for pre-action systems, if you're using pre-action in lieu of dry pipe system, you would need more devices, which would be more maintenance cost and greater reliability impact. So in reference to other means of freeze protection, there are advantages for dry pipe systems, but compared to wet pipe sprinkler systems, there are a large assortment of disadvantages. My recommendation as a fire protection engineer is almost always wet pipe if you can provide a environment to safely house a wet pipe system. Dry pipe systems have a volumetric limitation, or at least a volume of piping in which there are additional requirements for the system. So at 500 gallons and 750 gallons, there are extra requirements in NFPA 13. You can use fluid delivery time calculations to exceed these volumetric capacities. There's only one fluid delivery software out there, and it is rather expensive and cumbersome to do these calculations. I'll throw a calculator in the show notes for how to calculate the volumetric capacity of piping systems. Most of the time at the engineering level, you're guesstimating on size, but you'll have some idea of rough branch line and main piping sizes. And if you have a fairly large building, you'll know if you need to subdivide your system. Another design challenge of dry pipe systems is you cannot grid dry pipe systems. Gridding fire sprinkler systems can often be a hydraulically efficient way to design wet pipe sprinkler systems. Commonly, you'll see this configuration in warehouse spaces or large open spaces. This is because the fluid delivery time for systems filled with water is better when you have a gridded system or a looped system, but because of the disadvantage of the greater volume of air to be exhausted for dry pipe systems, you cannot use gridded systems for dry pipe systems. It is expressly prohibited in NFPA 13. Piping for dry pipe and pre-action systems in refrigerated areas are required to be pitched 1/2 inch per 10 foot. This additional pitch requirement for branch and main lines can be a considerable challenge when you are limited with the floor to ceiling height that you're given to route the piping in. So for instance, I worked on a project where there was a parking garage that had a dry pipe system in it, and we had a minimum clearance for the vehicles and then substantial structure in which we had to avoid with the dry pipe system. And so we were constantly battling trapped piping and then how to get our code required pitch for the dry pipe system. So it can quickly become a problem when you have to trap large sections of piping. You don't want to trap water. One thing we didn't talk about is dry pipe systems use a special type of drain called a drum drip. This is a drain that has a valve, an expanded section of piping, and then another ball valve. The reason why you need these two ball valves is because too much exhausting of air will trip the system, and so you want to be able to drain the water without letting out too much air. And so you open the first valve to drain the water into the expanded chamber, and then you close the first valve, and then you open the second valve in order to drain the drum drip. That's going to be it for this episode of Fire Code Tech. Hope y'all enjoyed it, and we'll see you next time. Thanks for listening, everybody. Be sure to share the episode with a friend if you enjoyed it. Don't forget that fire protection and life safety is serious business. The views and opinions expressed on this podcast are by no means a professional consultation or a codes and standards interpretation. Be sure to contact a licensed professional if you are getting involved with fire protection and or life safety. Thanks again, and we'll see you next time.